Alright, we're going to jump into lesson 4.2 for Math 3, which is on modeling and density. Start with a definition here of what density is. This is the amount of matter that an object has in a given unit of volume. And so we can find the density with this given formula. It looks like this. Density equals mass divided by volume. Okay, and so then oftentimes we're going to have to figure out what the volume of our object is, right, using these volume formulas. So if you don't remember those, we'll jot them down throughout the notes, and you want to keep those stored away. But if you forgot how to find the volume of certain 3D figures, you want to make note of that as we go through here. So here's the first one. It says determine which is denser. We've got these cylindrical logs of wood. So first we need to notice that these are cylinders, these logs of wood, and that's going to determine what our volume formula is, right? And so the volume formula for a cylinder is V equals pi r squared h. That's the volume formula for a cylinder, and that's what we need for this problem because we're dealing with cylinders. And then they give us two types of wood here. We've got the aspen logs and the juniper logs, and so we're just going to go ahead and find the volume for both of those. So I'll start with the aspen logs. So we've got V equals pi times the radius squared. They didn't give me the radius, but they did give me the diameter right here, which is 3.6. So I divide that by 2, and I get 1.8. And we're going to square that because it's r squared, and then times the height, which is 4.5. All right, and I can keep moving there, so 1.8 squared, and then I multiply it by 4.5, and I get a volume of 14.58, and I'll leave it in terms of pi, 14.58 pi for the volume. And now I'll go ahead and find the volume of the juniper wood. So that's going to be V equals, we've got pi times the radius, which in this case is going to be 1.5, right, because the diameter is 3, so divide that by 2. And then we'll square that, and then times the height, which is 6. I can multiply those together. I get a volume of 13.5 pi. Okay. And then I can use this volume in my density formula for each one. So I'm going to say D equals the mass, which they give me for the aspen, which is 1,195, divided by the volume, which we found as 14.58 pi. And then we can go ahead and evaluate that. If you're punching this into your calculator, make sure that you put the bottom of your denominator in parentheses there, and that's going to give me approximately 26.09, and that's the unit's going to be pounds per cubic foot. Okay, and that's because we are dealing with pounds and we're dealing with feet. And then we can go ahead and move to the density formula for the juniper wood. And so we're going to get the mass, which is written here for juniper, is 1487 divided by 13.5 pi. Again, using parentheses if we're punching this into the calculator, and we get 35.06 pounds per cubic foot. And then it's asking me which one is denser, and we can see that's going to be the juniper because we get the larger number there. So this is going to be the more dense piece of wood. All right, moving to letter B, same idea. So we're going to use the same formula. This time we are dealing with a cone. It says a piece of cheese has been machine carved into the shape of a cone. All right, so we got a cone with the dimensions shown. It has a mass of 169 kilograms. What is the density of the cheese to the nearest kilogram per cubic meter? So first we need to know the volume for a cone. So V equals, for a cone, that's going to be 1/3 pi r squared h. All right, and so then we're going to go ahead and punch these pieces in to find the volume of this cone. That's going to be 1/3 pi. My radius is 0.3 squared times the height, which they give me as 0.7. And I can multiply this all together, and I'll end up with 0.021 pi. So the process for that, if you're confused on how I end up with 0.021, I would first do 0.3 squared, then multiply it by 0.7, and then divide it by 3. And I'd end up with 0.021. So that's my volume for that cone. But remember, I'm not looking for volume, I'm looking for density, so I still need to find the density. And remember, we have D equals, and we're always going to have the mass divided by the volume. So the mass, they told me, is 169 kilograms divided by 0.021 pi. And I can evaluate this, and I'll end up with 2,561.64, and that's kilograms per cubic meter. So kind of a two-step process, right? First, we're finding the volume, then we're finding the density. Okay, keep it going here. This time we're dealing with spheres, because it says a spherical tank of gas, right? Spheres. So we need to know the volume formula for a sphere, and that formula is going to be V equals 4/3 pi r cubed. Okay, and they give me two different tanks of gas here, so I'm going to find both of them. So I'll start with the volume of the oxygen. So we'll start there. That's going to be V equals 4/3 pi, and then r cubed, the radius they tell me is 0.8. And I can go ahead and evaluate this, and I'm going to end up with 2.14. Right. Okay, and there's a couple different ways you can do that if you're not sure how to do it, right? You can do 0.8 to the third power, right? Then you could multiply it by 4/3, and then you'd multiply it by pi at the end. Okay, but we're just punching that into our calculators to get 2.14. And so then I can go ahead and find the density here. So D equals, remember it's mass over volume, and we have a mass of 2,477 divided by the volume of 2.14, and we get our density of 1,157.48, and these are kilograms per cubic meter again. Okay. And then for the hydrogen, second formula here, so we're going to say V equals 4/3 pi, the radius, which is 1.2 cubed. And again, I would do 1.2 cubed, and then I would multiply it by 4/3, and then multiply it by pi, but you can actually do it in any order. I end up with 7.25. And now I can go ahead and find the density, which is the mass divided by the volume, so that's 514 divided by 7.25, and we end up with 70.9 kilograms per cubic meter.